Have you ever wondered why understanding solubility is vital in the field of physical pharmacy? Well, let's unravel this mystery together. Solubility, in essence, is the property that enables a substance, known as a solute, to dissolve in a solvent. For example, when you stir sugar into your morning coffee, you're witnessing solubility in action. But how does this apply to pharmacy, you ask? Well, the principle of solubility plays a pivotal role in the creation of medicines. It influences how well a drug can be absorbed by the body. Think about this. A medicine that doesn't dissolve well may not be able to reach the bloodstream effectively, reducing its therapeutic effect. On the other hand, a drug that is highly soluble can be quickly and efficiently absorbed, providing faster relief. So, understanding solubility isn't just a scientific pursuit, it's a crucial aspect of making effective medicines. Now that we understand its importance, let's delve deeper into the different types of solubility. There are three main types of solubility: saturated, unsaturated, and supersaturated. Let's start with saturated solubility. Picture a cup of hot tea. You add a spoonful of sugar, it dissolves. You add another, it dissolves too. But at some point, no matter how much you stir, the sugar just won't dissolve anymore. The tea has reached its saturation point. It's now a saturated solution, meaning it contains the maximum amount of sugar that can dissolve at that particular temperature. Now let's consider unsaturated solubility. Imagine you've just brewed a fresh pot of tea, but this time you've only added a single spoonful of sugar. You take a sip, but it's not sweet enough, so you can still add more sugar and it will dissolve. This is an unsaturated solution. It's not yet reached its saturation point and can dissolve more solute at the same temperature. But what about supersaturated solubility? Let's think about that cup of tea again. This time you've managed to dissolve a lot more sugar than you usually could because you've heated the tea to a boiling point. Then you let it cool without disturbing it. As it cools, it still holds on to all that extra sugar, even though normally at this cooler temperature it wouldn't be able to. This is a supersaturated solution. It contains more solute than it would be able to dissolve under normal circumstances, and it's unstable. A slight disturbance, like a spoon stir or a sugar crystal, could cause the excess sugar to suddenly crystallize out. Each of these types of solubility plays a unique role in physical pharmacy. It's crucial to understand how they function and interact. Whether it's about maximizing drug solubility for better absorption in the body or dealing with the crystallization of supersaturated solutions, these concepts form the backbone of many pharmaceutical processes. Understanding them is key to mastering the art and science of pharmacy. Now, let's talk about the factors that can affect solubility. First up, temperature. When we heat up a solution, it typically increases the solubility of solids in liquids, making sugar dissolve faster in your hot tea compared to a cold one. However, when dealing with gases, the opposite is true. Think about a fizzy drink. It goes flat quicker when warm, as heat decreases the solubility of gases in liquids. Next, pressure. This primarily affects gases. Ever wondered why a soda bottle hisses when you open it? That's because the increased pressure inside the bottle kept the gas dissolved. When you release the pressure, the gas escapes. Finally, the nature of the solute and solvent. Like attracts like, so polar solutes dissolve best in polar solvents, while nonpolar solutes prefer nonpolar solvents. This principle, often called like dissolves like, is fundamental in understanding solubility. By understanding these factors, we can manipulate solubility to achieve desired results in pharmaceutical applications. We've covered a lot today, from the importance of understanding solubility to the different types and factors affecting it. We delved into saturated, unsaturated, and supersaturated solubility, and how gases, liquids, and solids dissolve differently in liquids. We explored how temperature, pressure, and molecular structure can change solubility rates. This knowledge is key for any physical pharmacy work, where understanding the behavior of substances in solution is crucial. Remember, a deep understanding of solubility is not just about knowing the definitions, but also about applying this knowledge in real-world situations. That's the essence of physical pharmacy.